Okay, should be live. And welcome back. I hope I can do a shorter one today because I need to get dinner. But yeah, let's look at the issue I was having with the hypervisor hanging. Since I can hang for any number of reasons, it makes sense to have a little watchdog timer on another CPU core to tell me when things go wrong. So I thought of doing that, but I just realized that I really need to commit everything I've done so far. So let me think about that first. See if I can do a bit of Git. Because there's a lot of stuff here. It's gonna be separate. The stream does work, right? I think YouTube did one of the silly things it does where like it didn't load the first time on the site, but I think it's fine. So, that's IPN. Oh, someone's asking about the Asahi progress report. Yeah, that's on my to-do list. I've been procrastinating on that. But yeah, I'll get it done really soon now. Sorry about that. I have like two queued up now. One about the kernel merging, and then there's going to be a big one about this hypervisor stuff covering April and May. So I need that. Was that all? No, I need types. I think that was just the rename of that, yeah. I think HV hook type, HV entry type, yeah. And, but I don't necessarily need these two changed. Oh, I just realized that that's broken. I think that works. Of course it doesn't. I'll fix it. Do it here. HV.h. Oh. Put the HV Python thing in there too. I think that's in proxy. Yeah, that. Hook VM, not those. I do need those, not those. Not doing the new ones. Hook VM. Oh, those aren't even in order. Is this done? Yeah. I think that's everything for that change. Hook, HV hook type, yeah. Yeah, sounds fine. And a lot of this is probably going to end up in one big commit. Let's see what we have. Yeah. Turning on GXF, then that's for HICR trap bits. That's a different story. Actually, let me do that separately. Put that one in there. And let's see what we have. There's a lot of random things in here, but it all kind of goes together. The only thing that I want to kind of do separately is this with the moving the regs 31 thing around. So I'm going to do that now. Nothing in here for that. I think nothing in here for that. Yeah. But there's going to be some stuff here. Split that. Oh yeah, that was the handle thing. That needs to go in there. So let's do it like that. Not py, not c, not h, not that, not that, not that. Not, yeah, that needs, oh, did I skip that? I think I skipped that. Okay, those need to go away. That goes in there. Not that one. Not, oh, I forgot that. I need to move that. It needs to go into the other one. Yeah. And then the exceptions, not that, split that, not that one, yes, that one. And then this I need to edit because I only want to do that one for now. And then here, yeah, if handle, do the thing, otherwise proxy lower and no exit. So get rid of that. And that should be most of that change. And yeah, we'll do the exit thing later. Okay. Actually, yeah, that should do it. And okay. NVM sync trace. It's going to do 1000 milliseconds on that, and actually 1500 just in case. And I need to do that later, yeah. And then just kind of all the hypervisor exception stuff. So I want to have the tick support. Let's do that in source first. Not the GXF. Split that. Let's put the tick rate, tick interval, split that. And then that is not necessary. Wait, why is that? Why is that commented out? I guess if it's already enabled. Hold on. Did I break that? It doesn't need to be like that. And if I'm just doing the tick, I will do not those yet. Not that. I'll fix that later. Update FIQ, handle MSR, no. Exit, no. And then those are not necessary. Oh, damn it. Don't that. Don't that. No. Split. No. This one. HIQ, FIQ. I will only do the tick for now. I want to do the vtimer thing in there too, so not those. Let's just put vtimer in there. And no, just put that one in there. And I think we don't need anything else there right now. The only tricky thing is that count v thing is going to go to the vtimer. So for stepping, I do kind of want to do it like that. So not those. Split. Not that one. No. And then it's basically if self-stepping or not handled, then stepping is false. And not those. Don't need that in there. And we can use that. And I don't think we need. I need those there. Yeah, split. Not the user interrupt one, but the vtimer, yes. Not any of that. 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 I think that will work. Yeah. Okay, and now let's do the GXF stuff. And we need Okay, so not the user interrupt stuff. I don't need UART for that. Okay, so most of this is going to go away. We'll add that later. For now, let's just do the exit function and just do the dev read thing. Not that, yes, that, yes, that. Split that, edit that. Get rid of that. And then this user interrupt and handlers again pending. Yep, all of that and all of that and all of that and that, but not that. Not that. No, I need to add FM mode to the other. That's only going to work if I do that. So. And SIGINT. Yeah. That'll be a fix-up for the other one. But then I need to add the guest timer stuff. Actually, this should really go afterwards anyway. So not that. Nothing here, not that. And then I need the sysrex. Sysregs. Not that. Split. Yeah, all of this is fine. We can do IPIs and a guest timer at the same time. Yep. And yep. What did I touch in HV.C there? Should be fine. I'm eventually going to have to add some of this to the commits. I guess I might as well do it now. But I'll do this first. I don't need that. Why is that? Mia, hold on. Clean up some garbage that I have laying around. Yes, that goes away. That doesn't go away. That doesn't go away. That, I don't know if it's necessary or not. That goes away. I don't think I need your.h there for anything. That was for the debugging. And that doesn't need to go there. And then finally, yeah. I guess this will work for now. Pretty much. Actually, no. Let's do this stuff first. And IPIs should have been done. We don't need those. There. And then those can go away. Okay. Not that, not that. And you can do that one. And finally, yeah, let's just throw kind of this stuff on there first. This, and yeah. That's not necessary. And finally, I have a clean tree. And I can push what I have. So let me fix the... oh, what was that? I already forgot what that fix-up was. Oh, that, yeah. Yeah, that is that one. I think that's all the fix-ups. Yep. And I need to do that thing. Okay, let's push that for now, and then finally I can get some work done. So, hypervisor Watchdog. I need a new file for this. Oh, not py. Where did I get py from? Let's see. Okay, so a bit of a copy and paste here. I don't need hg.h probably, and probably utils. So void hg.ut. What's that STFU thing? It's just that. So yeah. I need to figure out how to like this is going to be a synchronization issue. Probably this is enough to stop it from like assuming things about that variable. Yeah. So I need a static U64. That's pet. Shiz, I know you're saying volatile, but volatile is evil, okay? You're not actually supposed to use volatile for SMP. You're supposed to use volatile for hardware registers, and that's not really relevant to modern hardware register accesses anymore. What I really want is like an atomic type or something like that, but I mean, these are going to be atomic anyway, so like as long as the compiler understands that as long as you have a barrier, it's fine, basically. And that barrier is the sysop, so which should be declared as memory, I believe. If it isn't, then that's a bug. Yeah, it is declared as access as memory. So like this is where the volatile is. This is the volatile you want. So unactive there, pet. Okay, then we just set the timestamp. What was the physical timer value thing? The register I want for this count. Pt.12, is that what it was? No, count. That one, count PCT EO0. Yeah. Mm-hmm. Not that it matters with the 64-bit value, which is, but for what it's worth, this is how you do this check without screwing up wrapping. The compiler cannot keep HVWT active in a reg without volatile because this is an assembler operation that claims to possibly access memory, which means the compiler knows this, the compiler believes this assembly might modify the value of HVWT active. Actually, put S does a new line, doesn't it? I think I don't need that. I do need I need that, and I also need UART.h. And now the tricky thing is I need a UART printf because my IODev stuff is going to go all over the place, and that's not what I want. Plus, that's also not SMP safe or anything. So, not that the UART stuff is massively SMP safe, but at least it's a bit more SMP safe than it. So, I think the worst thing that the UART code is going to do is send 2 characters at once, which is probably fine because of the FIFO. And yeah, it should be fine. I do eventually want to support SMP and have like proper locks and stuff, but for now this is going to hopefully work. But I do want a printf here, which means that I do kind of want a UART printf function at this point. That's going to be handy anyway for debug use cases. I forgot my printf buffer is only 512 bytes. That could overflow in some weird cases. I need to remember that. Especially because I'm not using the VSN printf. Why am I not using the VSN printf? I do have VSN printf, don't I? Yeah, I should do that. And while I'm there, did that set the freaking null thing properly? Including the terminating null byte. What does that mean? What does write at most including the terminating null byte? That's not... That's ambiguous. That... Does it? I think it's not going to terminate in that case. It doesn't. But it still doesn't say... That's not clear whether it terminates. I'm going to assume it doesn't. Are you sure? Okay, it does do it. Okay, cool. Okay, we got that, and let's put that in the UART.c. Okay. And then it's just UART write. Oh, but then the return value is the number of... yeah, I actually need a min on that. I do have min max here, don't I? Yeah, so... I actually don't care about the null because... I don't care about the null because this is UART write anyway, but... oh, I'm not doing the new lines properly here? Put char? Oh yeah, it only do put s. Ooh, that's interesting. Oh no, I think the console side does the new lines, doesn't it? IO dev. Or maybe it doesn't. Maybe it doesn't. Maybe I've been dropping my my carrier's returns. Oh well. Still works with my terminal config anyway. Yeah. So anyway. Min I... And do that in utils too. Okay, so let's add a UART printf in there, which is, that's how I want to do it. And it should compile, hopefully. Okay. Do that on the utils too. Okay. So I want that, and then in hvwdt.c, well, we can do put s there for that one, and then let's just do it. Okay, and then here in start, I need set a timeout. So let's do 1 second, and I actually kind of want to do this differently. I want to do this. If it's not enabled, let's just do the DMB here. And then if it's not enabled, we can just continue. Or actually, we can do it here. Yeah, that works. And then I can put this up there. And finally, I need a... I want to put a uSleep here. Should be enough. I said uDelay. Actually, let me add that to the makefile first. Helps if I save that. Yeah, well. It's uDelay, isn't it? Where am I? Here, DSB, pet, and smp.c. Format that over here. And, oh, it actually, I thought that was SYU by default. I guess it isn't. Okay. Actually, I don't even need a SY for these. I just do IS. Is it IS? No. I forgot what the arguments for that were. Yeah, IES H is what it was. I'm sure there's a more a narrower way of doing that, but I'm not really here for this. Not about to spend a ton of time thinking about concurrency for this one. Okay, so I just need these functions, basically pet, suspend, resume, and then start and stop. Yeah, right now this is all single CPU. Once I do have multi-CPU, I'll just steal one. So here's that, and then we include. Is that only? Oh no, I don't even need the C file. Sorry, the H file. Sorry, I forgot I'm putting all of these in the same place. Let's do it like that. Delete. Okay. Did I save that? Yeah, here. Okay. Well, Mac OS is the same CPU as the hypervisor. That's why it's a hypervisor. It runs on the same CPU. So this is a different CPU that is not used right now. So here, yeah, timeout is equal to that times that register, which I'm using here. Yeah. And I want to make sure I hit it first and then call. Well, it shouldn't matter in principle, but yeah. And then finally, I need suspend and resume. And the ordering here does matter. I pit it first, then set it to enabled, and in here this is a bit dodgy because it might not. This needs to be ordered here. So it basically needs to be fvwt enabled. It shouldn't really matter if the other, like the on disable, because there's a delay here, and like obviously the timeout is longer than that. But on enable, I need to make sure that basically that, because otherwise we're going to be in trouble. This can go in here anyway. Resume. So pit and then set enabled to true. And in this case, pit does a store barrier. So I think that should work. Yeah. I'm not even sure if I need store barriers here, actually. I might not need DSBs. DMBs might be enough. But it's still probably a good idea to make sure the other code returns properly. So, and besides, again, I don't really care too much about this performance-wise. So, that should work. Okay. And then finally in hv.c, what I need to do is in hv init, I will also start the SMB stuff. And then here in HV start, it'll basically be HVWT start. The tick, enter the guest, and then stop. And then finally here in the tick, pet. And then the other thing I need to do is in the exception handler, I need to suspend and resume it around the proxy calls, because obviously that's going to be waiting on things. Okay. Apple already responded. Like, the CV is going to be made public tomorrow because that's the disclosure deadline. Apple knows about it. There's like, I'm not waiting for anything. I'm not waiting for them to, like, there's nothing for them to do really. Oh, someone's asking about continuing money. Thank you. GitHub sponsors has less fees than Patreon, so if you can choose, then that's a little bit better. But whatever works for you. Okay, so we got this. Let's see what happens. Let's see if the barking works. Let's give me some shells, and this is still running a broken thing. And also, the other nice thing is I can make it reboot when the Watchdog timer barks, which is going to be convenient, so I don't have to keep doing A reboots when it breaks. So let's see what happens. In principle, the secondaries got started here somewhere. Yeah. Oh yeah, I'm in super slow mode. I forgot about that. Aha! So it works, and it's alive, which is good, because it means the whole thing isn't broken. And indeed, it's worked. So I can kill that, and then that's going to be very convenient for me, because it means when the thing barks, I can make it reboot. Did this do a proper flush and reboot? Yeah, not flush, just reboot. Is that? Oh yeah, that was in. Was that in? Was that in? Yeah, that was in assembler here, wasn't it? Yeah. It does. Yeah, it just does that thing. So that's fine. And then it does a branch infinite loop. So cool. No, it's not once per second. It's a timeout of 1 second. But once it times out, it's timed out forever. So it spams. So as long as the hypervisor pets the dog at least once per second, it'll work. But actually, the hypervisor right now is petting the dog 1,000 times per second. So modulo, delays and things. So it better keep the dog happy. And then what I wanted to do here is figure out what the heck the main CPU is doing. So there's two things I'm thinking of. One is I can have some kind of memory. I don't even know if I want to do a buffer or something simpler. I'm thinking that probably the simplest way of doing this is just having a 64-bit sort of like record log thing, and that way I know what the hypervisor is doing. Like something very simple, right? And this will also help as a debugging tool. But The other thing is that there's a CPU interface that I can use to get information on like what the last instruction retired was for the main CPU. So I wanted to print that. So I'm gonna just have this in WDT. Let's do. I'm gonna call it H3 WDT log breadcrumb. And it's just gonna be characters for now, and that way I can just have a little 64-bit basically when I do the initialize, I'll just, what's the nicest way of doing that? If I'm setting it as the LSB, that'll be the newest thing. So I wanna put it at the top, and then no, I want to put it at the bottom so it pushes forward, and then yeah, and it'll print backwards, but that's okay. So basically, set it to 0. Yeah, that's okay. Because I want it to be an atomic right, but I'm not sure how to get it to do that. It'll probably do it like that anyway, though. I think there's probably some way of making it atomic, but anyway. It'll probably, I mean, even if it isn't atomic, it's not going to be a huge mess. I need like a write once macro. How does Linux do that, actually? This is basically what I need. I think that's an architecture-specific thing. Oh, that does actually use volatile. So this is the use case for volatile, actually. Yeah. So I do want volatile for this one. Do I need a barrier here? Yeah, probably a good idea. But a DMB should be enough. Honestly, I think a DMB is fine for all of these. For suspend resume is probably a better idea. I just want to make sure it's committed, otherwise it might, well, it's not going to happen, but it might time out. But for petting, I'm thinking a DMB is enough. In practice, anyway. And then in here, so what I'm thinking is I can do, like, I was previously printing this with the UART and it sucks, right? So this way I can do it like this. Actually, E. I probably want more than 64 bits for this anyway, to be honest. But for now, it'll be okay. And that's for handle MSR, and then in VM, actually we can just do it here. And then finally in here, I can pretty much just print the breadcrumbs like this. I should probably copy it, but it's little endian, so it'll be in the opposite order. But I need a null at the end though. That's gonna be okay. Let's do it properly. Let's do it properly. Not put this. I need UART. I don't have a put s without the new line, because put s always put the new line on there. Just annoying. So and I want to go from actually from 56. Put down 0, subtract 8. That should do it, I think. So let's see what happens. And now also I'm going to not make it super slow with the synchronous UART thing in here, because I don't think I need that. Is STD atomic in that thing? Is it in? Yeah, is it here? Yeah. Oh, but this is the full compiler thing. Where's the GCC stuff? Hold on. I need. Does this work? I think it works. Yeah, this GC Live R64. Okay, so standard atomic in here. Oh, it is. Cool. Excellent. Did not know that. Okay, so we can do that. Let's see what happened here, though. Okay, I think that heading. Yeah. Okay, back here. Hey, XF, cool. Oh, that's interesting. Yeah, so it closed an FIQ and then it died. So it's dying in. It was ticking basically. It was ticking when it died. So, but it's nice that it reboots for me. I kind of wonder if it's a guarded execution thing. What were the vectors? Oh, the vectors here do print everything if it breaks. So, and then it's basically sync is the only thing that might happen, and that does some stack pushing, and then it goes to it goes to the regular exe sync. That's actually kind of interesting. That's not necessarily what I want. Just in case, I'm going to try doing that. Just in case we are dying here. Let's see what happens with that. Actually, you know what? Yeah, it just... Oh, and this time it was different. This time it died on a synchronous thing after doing what? A lot of page faults? Where did it... like, yeah, so you see, sometimes it dies in different places. But it's always in the guest, right? It's S, something S. And it was handled as a... what was A? What was A? Or I forgot what things are. Oh, the implementation defined thing. Yeah, so it was an FIQ register probably. Sorry, an API register. So yeah, okay. Let me use standard atomic now to take care of that properly. And what does this have? Atomic car, atomic everything. Yeah. So basically, I guess that's what I need. Atomic event least 60 fast 6040. But the thing is, I don't actually need atomic operations here. Atomic operations are for when I need to make mutations that are atomic, but that's not the case here, because here what I actually just have is one thread reading, one thread writing, which does not need atomics. What I need is just like a write once. There are no partial writes. The like what's the name? Where am I? Here. These types are all like inherently atomic types. So there's no way one CPU can observe a partial write. This is architectural. This may not be portable, but none of Mini is portable, so. So I think the atomic thing is going to be useful once I actually implement this in P, because then I'm going to need actual atomics and to build my own like spin locks and primitives and stuff. Is the compiler allowed to split writes to? That doesn't really make any sense. I mean, yes, technically it can. Why would it ever do that? If it's a volatile, I don't think it's allowed to do that. And bools are Boolean, so I don't care. It's either true or false. And the timestamp could be partial, I guess. But again, that gets fixed by volatile, so. And the timeout does not need to be volatile. I don't know what bool is aligned to, but whatever it is aligned to, it's gonna be atomic. Like, volatile will do the write once semantics for me, so. Actually, what if I just implement write once anyway? Well, it's not needed now. This is good enough for this. Let's not overcomplicate things. I already spend enough time agonizing over concurrency issues when I'm writing, proper Linux drivers. I don't want to have to care to that extent when I'm writing a hypervisor for experimenting with drivers. Believe me, I've had enough of that, and I'll do it when it matters. So anyway, that works, and we don't get anything. So I'm kind of curious now. This will tell me, because it's dying in macOS. It's not dying in Mini. It's not dying while printing to the the USB. So it's entirely possible that the proxy still works at this point. And in that case, I can just do this basically. And then the reason I need for this is start HV. And then in here, and there's nothing there. And just like that. Obviously not any of that. And then whatever happens, we're going to reboot. So, because this will let me inspect things, which is going to be quite useful. Where is this? Yeah. I do the bark, and then handle an exception, basically the same thing. And, well, this is going to be the last thing anyway, so handle exception, I don't need any of that. It's basically just going to be a shell at this point. So most of this, and I'm going to delete some of that afterwards anyway, but in handler true. Second thing on stepping false, and then just set the locals, and follow this. And at this point, I mean, this is dead, so. We're going to repeat this through the interface. Actually, I can just send the breadcrumbs over with the info thing. Do I care? Did I have putis? I don't even know if I have putis. Probably not. Just printf. Let's see what happens. So we're here, and we got HG.py, and there's a handlebar. Okay, let's see what happens with that. Because it'll be very handy if I can get an interactive shell on the secondary CPU when the hypervisor is in trouble. And if at this point it's looking like the issue is not that it kills my USB, because otherwise the breadcrumbs would be different. Oh, interesting. Oh, interesting. Oh, interesting. Okay, so the shell worked, but I got... Hold on. This time... Huh. Oh, okay, hold on. This is interesting. Oh, sorry, not primary core, so it does that. Yeah, I forgot about that. The console writes won't work like that if I'm not the primary core. So this is useless. The way it's currently implemented. So that's okay. I'll just look at the serial port to see what I'm doing. But it's alive. So what's with the stars there? How's that about? Who? Do I have a... Oh, sorry. Yeah. Yeah. Yes. I have flushes in there, and those are triggering this. So obviously, if there's something to print, otherwise we're going to get spammed. Didn't think of that. Okay, cool. So where is that CPU information stuff? Where are we? Because that CPU has to be very wedged if it's going to be very wedged if FIQs and stuff aren't working. So let's see. I know there's some stuff in here like retired. Yeah, this stuff. This thing. Basically, I want to steal that. Well, I can't steal it because of license issues, but I want to see what it's doing. Yeah, this thing. Ooh, interesting. So you need a read from that. Okay, let's make a new file for that. And I think this is actually some standard stuff documented for ARM, so I have CPU regs. Let's do it like that. That's weird. You need a 32-bit read, and then you get a 64-bit write. Why? And then he needs to retry. This is so weird, but okay. Yeah, so the UTT debug regs thing, I think we have that in the ADT. Yeah, it's in there. So in the Watchdog timer init here, what I'm going to do is get that. Let's just do it in a separate thing. Probably rename this then. And for the these basically. Actually, let's do it like this, and just like this, and okay. What did I just do? Okay, need ADT in here. Okay, that should get me the registers, and then let's see about that. So, I don't know if this is... No, this isn't core side. It's actually... This is probably actually a... Is this a thing? Apparently it's vampires. But yeah, this is giving me a lot of things that have nothing to do with... Yeah, okay, this is... at least Project Zero has some stuff. Interesting. Oh, there's a hot CPU with state. Oh, that looks like fun. Very interesting. Oh, so we get to run instructions on the CPU, huh? Neat. And very handy because I have these MSR wrappers I can use to do this. I mean, this is all code I have here anyway, right? But apparently I also need the core side registers, which is interesting. I mean, I don't know what UTT is, but this is probably going to move to another file eventually. But let's see what we have. So UTT, I'm still in the shell there. So we got this. Let me read that. Yeah. Actually, this debug stuff might better be implemented in Python anyway. So I might not even do this. I might just delete this and do it all in Python. So let's see. Let's see what they're actually doing here. Yeah, this 64. Yeah, so it needs UTT, which is the one we have. So That's 0. Okay, very useful. And then it just sets it to debug fault, which is that apparently. So I guess I kind of want another file for this. And also I'm going to be importing it from here, so let's do it as another file. Which means proxy client. I'll change that later, but yeah, so it just sets it to that, and then waits for halted, which means probably just reading that and debug ACK, and that's it. Where is that? I just at the top of that. 28. Okay. Is it 32-bit? Oh, we don't even know. I'm going to go ahead and assume this is 64-bit. Okay, so we do that, and then stuff instruction is going to be the fun one. Ah, but that does need the core site registers, huh? Yeah, so the core site ones are these. And this is the core site access thing. Yeah. So we have CPU, and then we need we have the core sites, and So how does that work? Well, this is going to be standard Apple stuff, so I don't even want to read that. Might even be in here. Actually, I wanted to first get the program counter, which I think was in debug wrap. So this is first useful, and this is just UTT debug, which is the same thing. PSCR offset is 90. Okay, so let's get that first. Yeah, so let's just do. And apparently it needs a read 32 of. Also, is the debug wrap thing? So what's this? Why does it drop that many bits? That doesn't make sense. Oh, sorry. If okay, yeah, it's padding. Yeah, that's fine. Yes, apparently it needs a read and then a 64-bit read. Let's just do it like that. 48 bits should be 16, like that. Okay, let's see what happens. What was that? This import. Import lib. Oh, but that's already there? No. Yeah. So let's go in here. CPU debug. Yeah, UTT looks like something custom, but then the core side stuff is that didn't work. That's not working. Okay, so what about the PC thing? Yeah, P. I'm dumb. Okay, so maybe the debug stuff doesn't work, but at least I know what is. Okay, interesting. What is that address? Huh. That's mini. Haha. Oh, cool. I get to find a mini bug. I knew it! It's fucking GXF. I knew it. Ha! But why? It died there. And it died on... Well, that's so interesting, though. So it's like it tried to take a guarded execution exception, and then something went horribly wrong, and it couldn't execute a single instruction. So I wasn't off when I made all those prints, but even prints don't work. See, the thing is, this might be one of those like illegal execution exceptions or something like that, right? Like, it like the PC is at the exception vector, but then it doesn't actually work, or like for some reason it couldn't fetch that instruction. Very interesting. Okay, this is a rabbit hole I'm not going to go down right now, but I'm very happy that I figured out this is what's going on. So I'm going to call it a day because I need to get some dinner and get some stuff done. But this is going to be an interesting chapter next time around. Cool. All right, well, see you all later. Probably tomorrow. And, yeah. Bye.